All right, here we go. Welcome to Lesson 5, Cavalieri's Principle. We're going to start out with the do now. Determine the volume of the triangular prism shown below. So remember, you should always have that reference sheet from the New York State Lesson 1. We attached it, and you just print this out, and that's where I'm going to find all the formulas. So all these volume formulas are right here. All right, so to determine the volume of a triangular prism, prisms are named by their bases. So the base is a triangle shown below. So the volume of any prism is capital B times H, and I'm saying capital B because the capital B represents the area of the base formula. In this case, it's a triangle, and 1/2 base times height, or some of you like to use base times height divided by 2. And this H here represents the distance between the congruent parallel bases. Okay, so that's how you know where the height is. Notice there's two triangles here. They're congruent, they're parallel, so the distance between those is this height. The base and height in the triangle formula are the two lengths that are perpendicular, that they form the right angle. So if these two triangles are congruent and parallel, the right angle is also here. All right, so when we plug into this formula, the volume is 1/2 the base of 3, the height of 4, and then the height, the distance between the two parallel bases, is your 5. Plug that into your calculator and you should get 30. If you like to put in units of measures, it's 30 miles cubed, but 30 would be just fine. All right, so remember, I might go a little fast, but always pause the video. You could try it out on your own first and then come back and see the explanation. An oblique circular cylinder, so here's a circular cylinder, so I got the volume of a cylinder formula. It's the area of a circle, pi r squared, times the height. The height, okay, which is the perpendicular distance, is 5, and the volume, okay, if we were to fill this whole cylinder up, it's going to be 45 pi. Determine and state the radius, so we're going to fill in what we have. We have the volume, so that's 45 pi goes right over here. That's equal to pi r squared times the height, which they told us is 5. So we're solving for r. The opposite of multiplying by pi is dividing. The opposite of multiplying by 5 is also dividing. We can do this in one step. All right, that leaves us with r squared. Whatever we do to one side, we must do to the other. So pi divided by pi, those cancel. That becomes 1. And 45 divided by 5 is 9. Then you know the opposite of squaring is square rooting. So the radius ends up being 3, and then we move on to the next page. Which brings us to these pictures here, Cavalieri's Principle on prisms and cylinders. What they're basically saying is the heights are the same and the base areas are the same, right? They all have A, they all have B. So let's bring it to something that you might be able to relate to. If you have 2 stacks of coins, in this case quarters, all right, the volumes, it says, given the 2 stacks of quarters, what do we know about their volumes? Well, the volumes are going to be the same because both stacks, look, they have the same height, okay? And they have the same number of quarters in it. One stack is just a little bit slanted, giving it a different shape. But the area of the bases, the area of the circular coins are going to be the same, and the heights are the same. So therefore, the volumes will be the same. So Cavalieri's Principle, once again, if you have equal or congruent, whatever word you like to use, altitudes, and the area of the cross sections parallel to the base are equal, then the volumes of these solids are also equal. Okay, so let's do an example. Again, you can always pause and go back if I'm going a little bit too fast for you. All right, it says the diagram below shows 2 figures. Figure A is a right triangular prism. Remember, prisms are named by their bases. Okay, so I know that the base is a triangle. So down here you'll see why I did the area of a triangle formula. And the other figure B is an oblique triangular prism. The prisms are named by their bases, so it's still a triangular base. The figure A has a height of 5 and a length of 8. Okay, so that's where I got this from. 1/2, a height of 5, and a base of 8, so the area comes out to be 20. And over here, the base of figure B has a height of 8 and a length of 5, okay? So the area of that base is also 20. So if we went to go find the volume, well, the volume of any prism is capital BH. Well, the area of the base, the capital B, is 20. They told me that the height of this prism was 14. This comes out to be 280. And if I find the volume of this prism, again, the area of the base is 20, and guess what? It has the same height. All right? So use Cavalieri's Principle and explain why these 2 triangular prisms are equal. Well, once again, if the area of the bases are equal, okay, the capital B, and the altitude, right, the heights are also the same, then you're going to be multiplying the same numbers, all right? So then the volumes have to be the same. All right, and that's what Cavalieri's principle says. If the base areas are the same, the capital B, and the heights are the same, then you're multiplying the same numbers. All right, let's move on to example number 2. Again, I got this formula straight off of your reference sheet. All right, Sue believes that the two cylinders shown in the diagram below have equal volumes. Is she correct? So let's fill this on in. The volume of this one is pi r squared times height. The volume is pi times the radius of 5 squared times the height of, 11.5. So the volume is 287.5. The volume over here, pi times, now this 10 represented the diameter. So to find the radius, 10 divided by 2, we're using 5 squared again. So guess what? The volumes are the same. All right, for the same reason that you just wrote on the other page. All right, so is she right? Yes. Both cylinders have the same base area and the same height. So therefore, the volumes are congruent. All right. The next problem, when the volleyballs are purchased, they are not fully inflated. So they want to know the difference between the radius. How much does that radius increase? So looking at your formula sheet, I found the formula for a sphere to be 4/3 pi r cubed. The volume of the partially inflated is 180. So we're going to divide by 4/3 pi. So that cancels on this side. And whatever you do to one side, you have to do to the other. So what I did in my calculus, I did 180 divided by 4/3, hit enter, divided by pi, and I got 42.971834. And the opposite of cubing is cubed rooting. So let me just rewrite that. This is the cubed root of r cubed. All right, that's how we're going to get r to be 3.50263. All right, I'm just going to write that down there. And then we got the volume of the fully inflated to be 294. All right, we're going to do the same math. We're going to divide by 4/3 pi. And you're going to end up with 70.18732299 equals r cubed. And then again, we're going to do the cubed root. That's the opposite of cubing, to get 4.124958. And now they want to know how much that radius increased. So you're going to take your, try not to round to the very end, all right? So try to use all those numbers that you see in your calculator to the very end, and you're going to get 0.62. Round to the nearest tenth. Your final answer is 0.6 inches was how much the radius increased. All right, we've got one more to go before you guys do your independent practice. And here we go. 1 meter is equal to 100 centimeters. So notice here, this was 450 centimeters, but they wanted our answer to the nearest meter. So I'm going to take 450 divided by 100 to get 4.5. That's where this number came from. And 825 divided by 100 is 8.25. That's where I got this number to be my length. All right, they want to the nearest tenth of a meter, the minimum height of the box, so that the volume is 139 cubic meters. So volume equals, this is a rectangular shipping box, so length times width. So the volume is 139. The length we're using is 4.5. The width we're using is 8.25, and we're looking for the height. So we're going to 139 equals 37.125, divide by 37.125, and you're going to get a height of 3.74, rounded to the nearest tenth. 3.7 meters is your final answer. All right, so I know I went a little bit fast on some of these. Always pause the video. Always feel free to try it on your own. Then come back, check your answers, and just go along with me. All right, so Cavalieri's principle states that if you have two figures that look differently, but they have the same base area and they have the same height, then the volumes are going to have to be the same. You guys are doing a great job. Just keep on doing what you're doing, and we will see each other soon.